So good morning, everybody. I'm Benjamin James. I'm actually a director for like a technical sales team at a software company. That's my day job, but my night job and hobby and passion throughout life has been philosophy and systems thinking. I stumbled onto cybernetics about 6 months ago, and it was like the last piece of the puzzle that I was missing. Um, and what I've been building over since then has been kind of a new framework for exactly what we're doing here in these groups is rethinking how we design for complex adaptive systems. And that's where my work, neodynamics and the spectrum of possibility and recursive choice come from, is more of the philosophical background and kind of how I work my way through this. So I'm excited to be part of this group because it sounds like I'm getting to go. I came very generally and universal with this idea. And there's a great opportunity to go into much more depth with each of you.
Did you mention that you published books in cybernetics recently?
Yes, I've published 5 books recently, as well as three white papers. Really, the first 4 books were more me working my way through these ideas. My background, my undergraduate degree was in psychology. So I actually came through this very similar to Ram from an evolutionary psych background, thinking of rethinking consciousness and how we think of that. And then kind of extrapolated from the individual to society and organizational systems, and then into physical and complex systems. And by the 4th book, I realized I kind of needed a new ontology and epistemology. And so I wrote a philosophy around this. And after that, I was like, this is a new science. I've got to kind of formalize this. And that was the final book, Neodynamics, which is more the synthesis of the other 4 into something probably more coherent for the masses. But it's been a very it's been like a 40-year brain dump. As I mentioned last time, I was diagnosed a few years ago that I'm autistic, and it kind of explains a lot of my social challenges I've had over the years around how I see the world. And so this has very much been putting my brain on paper because I've always seen a lot more complexity and nuance and nonlinearity than other people have. And I think I have a unique perspective for complex systems.
So that is a long time work, condensed, something in 6 months. You said you encountered like cybernetics in
Hey,
6 months,
Yeah,
and then you have
I've
to
never had
go.
that. I've never had that creative spark, so to speak. But this was
Oh,
my wife was like, you know what? Like we can take a break. I'm like, my brain won't let me. This has to come out. And there was no effort. It was just me. I wanted to stop, and it just wouldn't stop until it was done. So I'm like, it felt like a,
oh,
40-year brain dump, and now I
Ben,
get to spend 40 years unpacking it.
we welcome you so much. Okay.
Ben,
Okay.
you graduated from Brown, right? You went to Brown?
What?
No, I went to University of Southern Mississippi for
Oh,
my
Southern.
undergraduate
Okay.
degree. Yeah.
Okay.
Yep.
Yeah, but okay.
Great, great. Please
You
go ahead.
mentioned,
We have 3 presentations today. I
All
mean,
right.
3 discussions today, whatever you call it. But please go ahead.
Yeah, let me share my screen real quick. Make sure it's on the right one. Shoot, it's not two. Oh, all right. Can y'all see my screen?
Yeah.
All right, we'll skip straight into this. So, kind of the background where all this is coming from is rethinking exactly what we're doing here, is rethinking complex systems. But I came at this from the idea of adaptation and coherence in systems, right? We often our design is too linear and deterministic, and we doesn't really reflect reality. And so, what neodynamics is a paradigm shift to be minimally deterministic and maximally stochastic in our approach and integrate, look for universal principles that integrate across scales from the quantum level to everything in between up to, interplanetary systems. And this was a necessary and sufficient first principle synthesis of information, chaos, requisite variety, thermodynamics, synergetics, and dimensionality and scale variance. So I was basically trying to rebuild science from the ground up with what I knew and see if I could get something to work that was a little different. So this is that framework for adaptive systems, and it focuses on emergent behavior and iterative adaptability. And it's designed to navigate complexity and uncertainty effectively rather than trying to deterministically predict where it needs to go. And so what I've built out is 2 core frame constructs to map this out. The unified field of adaptive potential, which will map all of the possibilities, the material realities around the system itself, and allows the balance of information flow, chaos, and stability as that system seeks to adapt and maintain coherence within its environment. And then the spectrum of possibility and recursive choice operationalize this by essentially providing this adaptive field of choices and this iterative refinement choice to choice that updates the material reality of the system itself. And so what this allows us to do is kind of bridge from these more abstract principle designs about ecological systems, technology, or governance into a more actionable systems design perspective. And so I like to use Beer's steering analogy because I think it's very apt for how we're thinking about this. The unified field of adaptive potential is, it is the material reality within which the system exists. And that is the context within which the system exists as well. I think it goes back to Igor's point of, what is the system? It can be defined, an infinite number of ways because it does depend on the material reality, the temporal reality, and the perspective of the individual within the system itself. So, the unified field is both the boat's capacity to navigate, its adaptive potential, its balancing of chaos and stability. It's the operator, it's the rudder, it's everything that makes the system what it is. And it's those material constraints as energy reserves that define the possible range of actions for that boat. You could idealistically want to jump 50 feet in the water to the right, but that's not really within your adaptive potential. You're going to have to iteratively find your way there. And so that's where the spectrum possibility starts to provide this exploration of these diverse actions. And rather than trying to avoid failure, trying to embrace failure and embrace experimentation to find new paths. And so as the material reality of the operator of the sailor is trying to get to the lighthouse, he's adjusting the sail, he's shifting the rudder. But each of those choices is now changing that unified field. It's changing the material reality of his orientation to the lighthouse, his orientation to the water, his orientation to the wind. And it's now presenting a new spectrum of choices that are probabilistically either going to move him closer or further away to his goal of coherence, which is getting to the lighthouse. And so what this is, it's allowing this creative exploration, and then each choice through the recursive choice mechanism feeds back into the unified field. So we're iterating each time, like jazz essentially, and allowing the system to cohere on its own. And this is rather than us building a system to do something, this is allowing the system to become what it is and become what it should and evolve how it should to reach its coherence goal. So another example I like to use, since this came out recently, was with Willow. My framework for a lot of this really came from thinking of the understanding of quantum wave flux, where everything exists within a probabilistic state. That is kind of the reality, whether it's a quantum state or a decision that we're consciously making. It's a probabilistic state we're in until it collapses into some coherent function. And so if we think about what we do in quantum computing, current systems, they're too focused on error correction and suppressing those fluctuations, and they're limiting the ability for it to actually explore. What we're doing is essentially making these glorified classical machines. And rather than looking at a centralized approach to coherence, what we need to do is look at a more emergent approach to coherence. So this would be using the unified field to balance those quantum fluctuations with error-corrected stability, which allows the system to actually leverage that randomness for innovation, but still maintain an overall coherent goal. And ultimately, this would then allow it to iteratively refine its own algorithms through dynamic feedback and adapt its own computations in real time to those evolving conditions. And so what we get is, rather than a top-down control over a single or a certain number of qubits, we allow a decentralized architecture where the qubits collaborate autonomously and essentially create their own scalable, resilient system that can handle any type of complex computation. So where does this kind of build on and differ from cybernetics? As I mentioned, cybernetics was kind of the last piece of the puzzle. I felt like I had all these ideas. I'd learned about all this stuff throughout my life that I found was interesting, but couldn't quite pull it together until I sat through Stafford Beer's 9 lecture series on YouTube. I was hooked. But it's focusing on feedback, emergent behavior, and systems thinking, and to maintain coherence. But we're moving from this idea of static stability to dynamic adaptability and prioritizing fluid goals over fixed states. And then, this also integrates, as I mentioned, those necessary and sufficient principles, because I was able to model this out mathematically and simulate these systems with great resilience. So the framework works to that extent. And so, the way I see this, it's really supporting a new decentralized real-time decision-making model for how we think about systems design, as opposed to a command and control type of model that we've had traditionally in cybernetics. So this is the last one. So why neodynamics? Why now? I mean, I guess I don't think I have to convince any of you guys. We all know that complex systems require a new way of thinking. And this was kind of the language that I had to put together about how I see the world. And it seems to work, and it seems to fit both logically and mathematically to how different systems adapt at different scales recursively. And so I think it gives us a new insight into how we think about designing our systems to match reality as closely as possibly and as least deterministically as possible, as opposed to going the way we tend to be going, which is trying to be very deterministic and predictable about what we want as the outcome. We need to treat life as a little more jazz and ride the waves, not try to control them. So I know that was a lot, so I'm going to stop and open it for discussion and just leave this as this is where you can find some of my stuff. It's available for free, or you can get the books are available on Amazon if you'd like a nicer version than a PDF.
Super, 11 minutes. Okay, Jerry, you want to say something?
Well, sure. I'll kick off the conversation. I guess point one, okay. So you come at it from a computer. The problems of, from my perspective, problems of life and behaviors, psychological behaviors particularly, as well as life in general. You come at it from a point of view of classical logic, set theory, grounded mathematics, and yeah, you love chaos, so obviously you like differential equations, nonlinear differential equations, that sort of thing. So this is sort of an engineering approach then to cybernetics, as I understand it.
You could say that. I will say I'm not an engineer or mathematician by trade. I was very dependent on Wolfram and my philosophical background trying to translate that. But definitely, the way I look at this is the embrace of chaos, I think, is more the embrace of reality and understanding that reality is stochastic, not deterministic, or at least from my point of view. And if we understand that, then we should design systems that are minimally deterministic from an engineering perspective, because it allows them to be maximally adaptive and resilient, which is not the way that we tend to think about systems design today, from in my opinion.
So underlying the notion then of Wolfram's notion of the emergence of various forms starting out from a fixed set of positions, or some of his diagrams, I've forgotten what he calls his diagrams, but they have this emergent, a mathematical visualization of combinatorics iteratively applied. Is that your basic perspective?
You're a little beyond my technical depth in the mathematics, but I believe we're tracking on the same thing. It is looking at emergent systems from autonomously emergent systems, and leveraging mathematical frameworks to map that as close as we can, but understanding that our math is still a deterministic model that we're imposing on reality. So from a philosophical standpoint, I'm still assuming that even my model is a deterministic projection on reality that is it's the best we can do, right? It kind of comes to your point of cognition. I thought of this from a bandwidth perspective in information theory. We know that you can't have perfect compression, so any model in our mind is going to be a necessary compression of reality, and so is anything we think of from a systems design perspective. So from a mathematics perspective, it's not my depth or field, but that was how I tried to approach it. Was how do we do this with the least amount of assumptions possible?
A couple of comments in from that. Now that I understand more of the directions from which your thoughts are emerging, number one, I will send you references to a couple of colleagues that have pursued somewhat similar efforts at universal representations of nature, universal representations of systems that span hierarchical levels. So there's a couple of guys that I can recommend you might find useful to compare your own thoughts with and go, take it from wherever you wish from there,
That'd be
sort of thing.
fantastic.
And
Jerry, can you
both of them are computer scientists.
Oh, great.
So they'll
My,
have a lot
my
in
background's in
common.
technology, so I tend to think about this from an AI perspective a lot.
Yeah. Okay. So
Jerry,
the
can
other question that
can you give the names of these people you mentioned?
Yeah. Can you share it with all of us, please?
but are you addressing me, Jason?
Yes, I was asking if you could provide the names for the expert you
Oh,
just mentioned. You recommending Ben to compare the perspective.
yeah, I would have to. At the moment, neither of them. One of them is one of them, his name is Donald Palmer.
I know, former.
And Jason, we had a young man from Australia on a year or two ago, Verdowski, JD Verdowski, or something like that. You
Okay.
remember his presentation?
Yeah, I had. Or I guess you also trying to mention Stephen Weaver, the guy who did the theory of everything.
No, I'm not familiar with that.
Okay. Anyway,
Okay,
no
but
problem.
so that excuse me. So Benjamin, it looks like you've done a massive synthesis. The final comment would be, well, not the final comment, but an interesting question would be, do you see a path between this form of thinking and biological systems, and particularly just in general, the nature of life?
I do. My first book, Navigating Complexity, was very much focused on cognition and behavioral dynamics in general, just in individuals and society. I didn't go further than that, but Ram and I have exchanged a few emails, and it sounds like he's very much kind of digging even deeper in the cognition side of this. And I explore a little bit of the ecology in just from a applied perspective in the final book. So I think there's definitely a domain there in biology. I just haven't dug into it yet because it's not wasn't my strong suit in school, but it is something that I think I'd like to revisit now.
Mm, can you provide some examples about the spectrum of possibilities? Like how would you actually apply to a new situation? How how can you start using that scope?
Yeah. So let's go back to this slide just so we can talk through it. It's really about exploring diverse actions. So you think like within
Adaptive potential, I'll say.
correct, it is. It's within, think about instead of for like within an AI system, instead of deterministically, deciding, hey, these are the actions that are most likely to have the right outcome. It's allowing the system itself to have a probabilistic range of actions that it can explore in real time with real time feedback, as opposed to post-learning feedback. And so those could be, so for instance, I work at ServiceNow. We do IT automation. It could be an autonomous agent that is working on service requests, but because there's an outage that happens in another system, now the adaptive potential of the actual environment has changed, and the spectrum of actions that autonomous agent may take could be that, it's going to navigate more towards, resolving this outage as opposed to resolving IT requests. And so, but it's allowing that agent itself to make those decisions and find its own path as opposed to deterministically deciding which path it's going to take. But the reason this works is because each choice is recursive. Each choice then informs the next spectrum of possibility. So you can't think of it's not a cascading failure because you're not saying take this path of 30 choices. It's here's a choice. Now the new path is this. We're going to take this choice. Now the path is this. And so it's this consistent iteration that is then constrained by that unified field of material constraints, whether it's the architecture of the AI system, the environment that it's monitoring, or the material reality with which an individual exists. Each of those recursively informs itself. So it's really from I'd say almost taking it back philosophically to the individual. Thinking of your choices as less of making choices 5 choices a day. It's you're making choices moment to moment, and those are recursively redefining your own spectrum of possibility of the next choices you may make.
So what would be the methodology you put this all in paper, in writing? I mean, you're just making a list or making a table of probabilities or what?
So I've only gotten as far as building out the mathematical and logical framework. I'd like to get it into more of an engineering perspective, but that's not my background. I'm trying to convince some of my internal folks at my company to pick this up with our own AI platform. But that would be that's the one area I need some help and some digging into is actually how do we take this from theory and model into practice and operationalize.
Okay, Jerome, you put something in chat box, but I think everybody's busy listening to Ben. So why don't you speak up?
No, I didn't put anything in this chat, but that's just from Jerome.
I'm not in
Jerome, yeah.
a good place to speak right now. I'm just mainly listening, but I was just thinking about, and Jerry can probably speak much better to this than I can. When I heard about these non-deterministic relationships, chaos versus programming, I thought about Stuart Kaufman, of course, in his writing on simulated life and Boolean networks. So, but again, there are others here who are much more expert in that field. I was just throwing, name dropping. I'm guilty of name dropping.
Yeah, I do explore a lot of his work in my works, but as I mentioned, math is not my background, so I was stealing and choosing from as much research as possible and synthesizing with my philosophy. So, my next hope is that those more versed in engineering and math and disciplines can help kick the tires on this and run it through some rigor because I think I'm directionally correct, but definitely could use some refinement from some others.
Igor, you raised your hand?
Did I? Oh, no. Benjamin,
Yes.
I really like the approach, but I would like to know a bit more. And there are two things which intrigue me.
Everybody wants to learn a little bit more.
Yeah, well,
Yes.
first one is basically, how do you understand? You said you talked quite a lot about recursion, and then something about circularity. And I'm wondering what are you doing with that? And the second one, sorry for putting two out, but that's it, it makes it more interesting. You said you would like to put out basically a universal model. Universal models usually you test them to see if the general principle is working, and then go to the margins and say, is it really universal? Have you been thinking about how to deal with that? So basically, two not really related questions.
Yeah, so I'd say to the first question about recursivity, I think it goes back to just my view on reality itself, which is that everything is recursive and everything is stochastic. Our thoughts about control and prediction are just our own deterministic, ideations that we project onto the world. So, to me, everything is recursive. The questions you're asking me are changing the spectrum of possibility of the choices of answers that I may provide, which is then going to inform that is then going to recursively inform your next choice or your next thing that you say, and so that's where I kind of see recursion at not just at each scale, but also dimensionally as things transition between scales. And so that kind of actually gets me to the universality is I say I'm pursuing universality because I feel like I stumbled on universality, so I'm trying to be a little maybe a little cheeky and get people to really push back on this because I'd love to see where I'm wrong. But where this came from was essentially looking very much from taking the ideas around quantum mechanics and what we understand about probabilistic nature and the information entropy exchange within the operator or the measurement that's occurring, and taking that to a recursive dimensional level throughout each layer and building that mathematical model that I actually did in one of these, a materialist framework for emergent dynamics, was able to map quantum mechanics to black hole emergent phenomenon empirical evidence without the need for dark energy, dark matter, holographic theory, or any of these other string theory, or any of these other kind of deterministic convolutions we've gone down. I'm not sure that it's exactly right, but I feel like it's close to that. So I think those are, while you think you say they're not related, I think they are related because I think reality is just recursive, and we miss that and we overlook that And that is why I think, I'm kind of thinking this universality is trying to think of this not for me to explain everything, but for us to try and explain reality in the most simplistic way possible, for us to then design the simplest, most adaptive ways possible. I think we've kind of gone down this, in the Western tradition, this Platonic ideal of everything's very reductionist and very, separate. And I think we almost need to take a more Eastern approach and kind of merge these back together and be a little less worried about going deep and a little more understandable about holistically how all these things interplay, because those are those necessary and sufficient principles for us to do something universal, have that universal framing, even though it still will be deterministic to our best understanding. We're trying to be as least influential as possible. I'm a musician, so I think of it like jazz. You don't want to tell a jazz musician, which notes to play. You want to give them the constraint of the song and let them go to town.
Basically, self-regulatory subsystem, right?
Yep.
Go ahead.
Yeah, hi. Been nice to see you face to face. I'm
I see you,
looking
Rob.
forward to talking to you a lot more.
Yes, sir.
A couple of points. One is if you use the word iterative. I like to think of it as a Markov chain, only one step at a time. Because when a system is open and is subject to interaction with other systems or with the environment, you have no idea what is going to happen in the next millisecond or the second or whatever it is. So it is really, you cannot go back iteratively. Even like playing chess, you don't know what the opponent is going to move, right? So it is always one step at a time, and that is the Markov chain, and it's a memoryless process. So I shy away from iteration, prediction, error correction. All of those things are off my books. Especially because error correction, you can't really do anything because the input is like a sensation, output is an action. They are very different units, right? Input is coming from certain energy form and the output is going into something else. It could just be a thought. I could be right. You are writing an article based on some input that you are hearing. So yeah, error correction implies both of them are same units. So error correction is not an option. So what I do is then connect all these things. I use the simple process, a reflex as the fundamental operation. That is, every sensation is tied to a multitude of potential actions which are learned over the course of the life. So which similar to what you're saying, it's a spectrum of choices. But when you say spectrum, it gives you an illusion of continuous things. I like to make everything discrete. So I think of it as an N by M mapping, N sensations on N inputs on M outputs or M actions. It's a giant mapping. Then the whole brain process becomes like a GPS. Okay,
Right.
so I'll talk about it more when I give my presentation.
No, I think you hit on it there, which is I like the idea of the spectrum because I want people to understand that reality is fluid and but to interact with reality, we have to be discrete. And so we want to be minimally discrete, to your point, right? And so I think that's how I come about this philosophically is to say, how can we be as spectrumy, fluidy, as hippie science as possible, and then understand that when we actually want to make things happen, we need to be minimally discrete, minimally deterministic to embrace error as a mechanism for adaptation and evolution, as opposed to error correction and suppression. So yeah, I think Ram, as you said, we are in violent agreement.
Okay, yeah, thanks. Okay.
Benjamin, when you were you mentioned cybernetics and feedback, right, etc. What do you think about feedback? Has right now with RAM, you've discussed that it has basically little effects on the existing iteration, on the existing interaction. What do you think about feed forward?
I haven't given any thought to feed forward. I focused on feedback because I've made feedback iterative, and the reason I make it iterative and recursive is that feedback is real time. So that spectrum of possibility of next possible actions is informed by the immediate prior action. I haven't thought about feed forward though, so that is something I'll have to consider.
See,
Yeah.
feed forward is same as communication. So the next sensation that is coming in is feed-forward communication.
With regard to this, I think there's a certain logical tension here, which it runs pretty damn deep from my perspective. And that is that certainly living systems generate energy, et cetera, and actions through metabolic processes. And each metabolic process is a deterministic step, a deterministic operation in which one chemical structure is changed to another chemical structure. And this is necessarily determinist, and it's entailed by the structure of the system. And the concept of error removal or incorporation or either are not within the realm of a simple metabolic step. So I see this as a very foundational logical tension between your overall Weltanschauung and the way life works. But I'll come to that in my own presentation a little bit.
Yeah, I actually, you have some thoughts coming. I want to get into that.